Hey everyone. So hopefully you guys can hear me better. My throat is doing a little bit better, but I switched up microphones so that you guys could hear me better. And now my tool is gone. Oh, the joy. So welcome to chapter 19 with blood. And just a heads up, the book talks about blood in the context of the cardiovascular system and the heart. The chapter on the heart is next. So when we talk about the cardiovascular system specifically, we are including the heart and blood vessels. By convention, we call it, instead of cardiovascular system, we call it the circulatory system. We're including the blood, the heart, and the blood vessels. So just keep that in mind. Sometimes the homework and everything splits hairs. So keep that in mind. Also, it doesn't seem that my new tool is going to be fixed yet. My new tool is going to arrive today. I was hoping it would. But just in case, it's still making this stupid, Sorry guys, hopefully this will be the last chapter that you have to deal with that. I don't know what's wrong with this technology, honestly. Anyways, moving right along. Okay, let's see if I can actually move it along. Okay, here are your learning outcomes. I'm going to try to help you guys understand the difference in the components of the blood, as well as its functions for sure. You guys can read through all of these, but if you guys can master these, from ABO and RH, call these down and hit these and do the questions in the chapter throughout the chapter, as well as the ones assigned and mastering, you guys will be doing well. So just a quick reminder, when RH is discussed, they're talking about whether somebody has a positive blood type or a negative blood type. Some books may refer to it as the D factor. So if you have big D, little d, you'd be a positive. If you have big D, still be a positive. But if you have little d, your blood type is negative. So we're not going to get too much into that, but it's good to understand. Actually, we are going to get into it. I lied. I'm sorry. So we're going to go through all these. All right. So again, here's where I was talking about the difference. The book calls it the cardiovascular system. We haven't quite gone to the heart. That's the next chapter. This chapter is going to focus on blood, which is by definition a connective tissue. It has a matrix. So, and it carries a bunch of stuff around. So keep that in mind. It is a very specialized connective tissue that keeps our fluids for nutrients and wastes and our gases, keeps them in solution so that we can get rid of the bad stuff and bring in the good stuff. All right, so again, here's your learning outcome. Those are not hidden from you. Try to change the color of this pen. I don't like red. It's scary. Okay, so again, it is a connective tissue, like I mentioned. It is a fluid matrix, and we're going to find gases, O2 and CO2. So when we get to hemoglobin, O2 is being dropped off, and CO2 is being picked up. So when we respire, when we get to the cardiopulmonary section, you'll understand the function of the red blood cells themselves, which I abbreviate RBC. And if I say plural, sometimes there's an S there. Okay, so we're going to get through all of these. I mentioned new gases, nutrients. We just did hormones for the endocrine system. So keep in mind that hormones are blood-bound. They are not airborne, they're blood-bound. And if it's being released and it needs to get to a target tissue or target cells, it's going to be carried, hormones are carried by the blood to their target tissues and cells. So, and again, we're going to remove metabolic wastes such as CO2, which I mentioned up here. We definitely need it to keep homeostasis going on. So we have to regulate. The blood is going to regulate our pH, which is slightly alkaline. It is between 7.35 to 7.45 on the pH scale, which is 0 to 14. So it's slightly alkaline. Ions such as sodium and potassium for the functioning of your heart and muscles, and calcium. Well, sodium, potassium for your heart and muscles, and then also calcium, as well as fluids that are in between the tissues. And anyways, we'll get more into that when we get into the immune system. So we're going to talk about clotting for a while, so that if there's an injury, there's a process, and I'll go over it in detail, that is going to restrict us from losing too much blood. All right. And then we're going to see white blood cells, not erythrocytes, but leukocytes. And we're going to see them here. And then we're also going to see them when we get to immunity. So I would ask you all to go ahead and learn them now, so that you get the points on this test, and then you get the points on the test when we get to immunity. Okay, and then our blood does help us stabilize body temperature. Interestingly enough, our body temperature is, if we're talking about Fahrenheit, 98.6 degrees Fahrenheit. Then the blood is a little bit warmer. It's about 100 degrees Fahrenheit. And we'll get into a little bit more of that later, but you don't need to memorize that. Again, I'm so sorry this looks so ugly, guys. I have ordered a new pen and new tablet, and they should be here soon. All right, so this is the typical in Fahrenheit for blood. This number, I would have you guys know when you move on, if you're doing nursing or pre-med, you're going to want to know Celsius. So just make sure you're aware that human body temperature is typically 37 degrees Celsius. The blood is going to be a little bit warmer. When they say viscosity, they mean like thickness, or the ability or lack of ability to spread something. So the blood is far more viscous than water. I already mentioned that number. My cat just knocked something over, if you heard that. Sorry. Okay, so I already mentioned this number. These numbers, 37 degrees Celsius, pH, these are good numbers to have in mind, because you're going to need to pull them out of your head if you're applying them in a hospital setting or a doctor's office setting. All right, so if you take 7% of your body weight in kilograms, you can get the approximate number of liters or quarts for blood. Hospital settings, medical settings, science generally is going to use metric, so it would be liters. Oddly enough, though, they rarely use kilograms. They use usually the 165 pounds, or I'm sorry, they use pounds. So if you were to see something like this on a test, I would probably already have it in kilograms for you, and then you would just have to take 7% of that. So if it's 75 kilograms, you would multiply it by 0.07, which gives you the percent, and it's about 5.25 liters. So you could type that in nicely, and make sure you put your units in there. So, but I would go ahead and put it in kilograms for you, so you don't have to do that conversion. If you see that it's in pounds, you should also see a formula to get it converted. It's not that hard, but anyways, moving right along. All right, so whole blood. It's good to know, guys, versus plasma. Okay. You're going to have plasma itself in the fluid and the cellular formed elements. So whether they're cells that are still together and not broken down, or whether they're being broken down to be recycled or disposed of, you're going to see whole blood consists of both formed elements and plasma. Whereas plasma, even though it's a great deal of the blood volume, is going to be 90% water, and then the ions we talked about, right? So potassium, sodium, calcium, etc. So keep in mind that this makes up the majority. It's actually more than the majority, 55% of blood volume. It is mostly water, just like we are, and so is our planet. But the blood is about about 45%. These are approximate numbers here and here, because about 1% of it, we'll see in a minute, but about less than 1% of it has other components. So, all right, when we fractionate these, we fraction these, we're separating the whole blood, right? So the plasma and the formed elements, they end up being on the bottom of a centrifuge. If you take a test tube and you put it in a centrifuge, these cells and cell fragments end up being on the, well, it's not quite that far, but they're down here on the bottom. And then the plasma will end up being closer to the top. And I have a much better image next. I think it's on the next slide. Okay, so here we go. Okay, okay, that's not the image I wanted, but shenanigans. Okay. This label is blocking what I wanted to show you guys. This is a heparinized tube. You guys can't tell that, but I can based on the lid and this. And when it's in this tube, when you take blood samples from your patients, it'll prevent it from separating it out. So if you have the heparinized tube, you will see that the plasma and the blood, the formed elements, stay together. If it's a non-heparinized tube, so if you were, and when you were meeting in lab, we would do a little blood stick where we collect blood in a capillary tube. And if you left it out long enough, it would separate. So you would see a yellowish kind of plasma up at the top, which is, again, mostly water and solutes and some proteins. Sorry about that. And then we'd see our platelets, which are much smaller than blood cells, our white blood cells, WBC, our red blood cells, RBC, and you would see them separate out again if they're not in heparinized tube. But heparin is a hormone or a chemical that was discovered, and we use it now to make sure that they don't separate out, so that labs can run and see what's going on with blood. And I'm trying to remember the name of the people who do blood work, hematologists. Anyways, so again, it's a connective tissue. What else do I want to say? Oh, obviously, if you go back here and calculate where to go, the weight, because men tend to be larger than women, they would have more blood. So that hopefully makes sense for you. So, and then hematocrit, we're going to get into this term more and more. I'll show you guys some of the calculations in a table that's important to know and be able to do. But it's the percentage of your formed elements in a sample. So that's why hematocrit is down here with formed elements, right? And then when we look at, what else did I want to say? Oh, hemopoiesis. This, I wanted to, generally you're going to hear me talk about hematopoiesis. And this is blood with the exception of, dang it. Hold on, I got to pause this. My cat's bothering me. Is it going to let me pause? No. Okay, go again. Okay. So hemopoiesis, we're looking at formed elements. So whether that's going to be your red blood, and where's my little guy? Come back, little guy. Red blood cells, platelets. That's hemopoiesis. More commonly, we talk about hematopoiesis, and we're going to refer to our. Oh, I think he stopped barking. Why are you being a poet? Okay. We're going to look a little bit at this. And the figure, I'll show you guys. You don't need to memorize the entire figure. I'll show you guys. It's important. And if you heard that, I'm sorry. My email is blowing up. Okay. So albumins, you don't need to memorize all the percentages here. But albumin itself is a very large player for plasma. One of the things I did want to say for albumin is if you changed if for some reason you become dehydrated or something like that, you change the quantity of dissolved, where are my words? Dissolved proteins. And this could be for all the plasma, actually. Oops, darn it. All the plasma. For whatever reason, the dissolved protein content goes down, you're going to see also a decrease in osmolarity. Which, don't worry, we're not going to be calculating osmolarity. That's not even a very pretty writing. Okay. But albumins are dissolved proteins. They are a very large contributor to osmolarity. They're going to help to get fatty acids where they need to be, which, if I'm not already told you, my abbreviation for fatty acids is FA. The hormones from the thyroid that we talked about in the last chapter, and some of our steroid hormones. There are 3 types of globulins, alpha, beta, and gamma. Alpha and beta are generally going to be formed. Well, we're going to go over them more when we get to immunity, but the alpha and beta are going to be formed in a different place than the gamma is, and that's not even a very pretty gamma, but we'll talk about where the gamma is formed later. All right, so these guys, they are going to, again, bind hormones. They're going to bind important metals such as iron. I don't use this word very often, but you'll hear me say lipoproteins. And then again, steroids. So you see the globulins, the majority is help them along with the albumins to get things where they're going. So fibrinogen is soluble. It's about 4%. You don't have to memorize these percentages, guys. But it's other than to know that whole blood, where'd it go? Plasma makes up about 55%. So there's more percentage-wise. Plasma is higher than the whole blood components. You don't need to memorize those little tiny percentages over here. All right. So for fibrinogen, so what you'll see is this is going to be acted on if somebody gets cut. It's going to be turned into fibrin, and that fibrin will help form a clot, and then eventually that clot will get broken down by another protein as the scar tissue comes in and heals. So this is where that is going. So it's going to stay soluble until a clot is needed. So for a paper cut or a small puncture wound, fibrinogen is going to stay soluble in the actual blood and plasma proteins up here. I'll show you, kind of put a line through on accident. Sorry. And then when it's needed, it will be converted to fibrin, which is what I was trying to write right here, right? So for fibrinogen to fibrin, and then the fibrin will help form a clot, like a root. Okay. And then that clot will eventually be replaced by scar tissue. All right. So, any other thing I was gonna say? I don't think so. The other plasma proteins of different enzymes and hormones are about 1%, a little bit less actually. Where's my little pen? Sorry. Are you not gonna let me change slides? You do not love me. Okay. Origin of plasma proteins, 90% come from the liver. So when I was talking about the globulins, alpha and beta, they're going to come from the liver. The gamma cells, on the other hand, these guys are actually produced from B cell cells. This is going to be so annoying. B cells, plasma, or excuse me, B cells that are found in plasma. And we'll talk more about that again when we get to gamma, or excuse me, immunity. So alpha and beta come from the liver, right, as far as the globulins, but the gamma which comes from our B cell or B plasma cells. All right. So antibodies will be made by plasma cells. These are, again, B cells, typically. Okay. And then we saw peptide hormones coming from our endocrine organs once they were made inside those. All right. So just to review again, for formed elements, we have our RBCs, red blood cells, our white blood cells, which are called, these would be called erythrocytes, or if you've taken Latin, red cells, sorry, red, and then leukocytes, that's a U sites, which is white cells. All right, and then we have our platelets, which are so much smaller. So this is your red blood cell, and it's biconcave, and it doesn't have this little creepy weird hair hanging out. On your platelets, it'll probably be about this size. They're just a small part of it. All right, hemopoiesis. So I was talking about when you're talking about the formed elements, all right? This does happen in bone marrow. And I'll get more into bone marrow transplants and some cool research later. But hematopoiesis is going to be talking about the formation of white and red blood cells. I don't know what that ding was, but I hope my video is still going. All right, so see how small these little platelets are. I'll stop here because I don't know what's going on.